Okay, we are given a quadratic function in standard form. We have y is equal to x squared plus 4x plus 13. And we know the graph of this is going to be a parabola. And in this video, we'll see how to write this into its vertex form, aka the transformation form, because that way we'll be able to make a quick sketch of the graph and we will be able to tell the range of this easily. The domain is just all real numbers. I'll show you guys two ways to do that though. First, we will complete the square. And I think this is the more legitimate way. So check this out. We have y is equal to x squared plus 4x. And let's leave a space here. And then let's write down plus 13. The purpose of the space is that we have to find out the number to be added here so we can make this a perfect square. And to do so, we have to first make sure that we have a 1 in front of the x squared. We do. So we can proceed. We will take 1/2 of the coefficient of x, which is 4. So we do 1/2 of 4 and then square. Work that out, we get 4. So that's the number that we have to add it right here. And immediately right after, we will have to minus that so that we're just adding 0, that we can maintain the original, right? Okay, and then if you look at the first three terms, just look at the first three terms and factor it. We get x plus 2 times x plus 2, which is x plus 2 squared. So we get y equals x plus 2 squared, and then work that out, we get plus 9. That's it. This right here is the equation in the vertex form. And here's another way to do it. Of course, if you want the vertex form, why don't we use the vertex formula? But I will say this right here is not so legitimate because completing a square is actually the way to prove that formula, right? But anyway, depends on the instruction. If your teacher is okay with using this, then do it. If not, then just complete the square. Alright, the vertex formula says the vertex is going to be at x equals negative b over 2a. Right? The vertex formula. Okay, look back here. We know a is equal to 1 and b is equal to 4. So plug in negative 4 over 2 times a. Work that out, we get negative 2. This is just the x. We also need a y. Y is going to be plugging negative 2 into the original and then just plugging into the x. We have negative 2 squared plus 4 times negative 2 and then plus 13. Work that out, we get 9. This right here is the h value, which is the x coordinate of the vertex, and this right here is the k value, the y value of the vertex. And the formula is y is equal to a times x minus h squared plus k. So of course we can just put everything in now. So we have y equals a is still the same as that, so it's just 1 times x minus negative 2 square plus k, which is 9. And of course, the 1 doesn't matter. You can just write y equals x and then plus 2 square and then plus 9. And here is the vertex form, just like what we got earlier. Same thing, of course. Now, let's make a quick sketch. We know the vertex is what? Negative 2, 9. If this is what you have, make sure that you do the opposite, negative 2. Right? Otherwise, worked out the formula, you can see that it is indeed negative 2. How can you make this 0? Right? X has to be negative 2. So the vertex is at negative 2, 9. And because we know a is equal to 1, which is greater than 0, that means the parabola opens upward. So we get a U shape, yeah? Okay, so let's say negative 2 is right here, and let's say 9 is right here. This is the vertex, and we will have an open up parabola like this. Something like that. It has no x-intercept, which is totally possible. And again, let's find out the domain of the range. Domain for parabola is just all real numbers. X is not on the bottom, x is not in the square root, so no worry at all. And the range is starting at 9, goes up all the way. So we have 9, but include the 9, so bracket, comma, infinity. Domain and range, right? I will say completing a square is more legitimate. again. So yeah, that's it.